Hello.
Very
I,
good. Best video ever.
I was like watching this intro and I'm like, I knew I added sound somewhere. Where is it? And then it started. Sorry everyone if you're listening on like headphones. It was way too loud, I think. uh, anyway, sorry about that. Well, welcome to Hoot number 60. It's a special Halloween episode, I guess. We can say we planned it, but we didn't really. So we just figured there's nothing spooky about Gateway API, right?
Not yet.
Not yet. Yeah. Uh,
Very.
but we'll see. I'm Peter. Alessandro's here with me today. If you're in the chat, if you're watching, say hi. We always like to see and hear where people are tuning in from. And what are we going to do today, Alessandro? What will we talk about today?
Well, a topic that is very dear to me and very dear to the community is represent the future of everything about Ingress in Kubernetes. So, and it's a long time coming. This API has been gestated for a long time, and I think we see now the end of the tunnel, like getting into GA. So we talk about Gateway API, which is very interesting name, right? So we talk a lot about API gateways. So, and there is this confusion, right? So it's not the same thing. It's very different beasts. And so we're gonna cover what is gateway API and how to use them also within the service mesh context.
Yeah. For me, it's very. I mean, it is confusing, right? Because you have like Gateway API. There are API gateways, right? But then there's also like coming from the Istio world. There's also a gateway resource that's an Istio, right? So these three things. And I think last time we did the stream on the certification, right? That was the thing that I brought up as well. It's like, oh, there are so many things, and I mean, named very similarly, right? So it can cause some confusion, but hopefully this will be cleared up today.
Well, I'm old enough to remember. I mean, a physical gateway, right? So that's why they all do kind of the same thing, right? So that they sit in front of a bunch of services and expose those services in some way. And I do remember physical gateways, right? So those machines that were now they are called routers. There's different names for them, but yeah, that's what they do. They expose services, computers, whatever, internal networks to the outside world. So there's always like an outside and an inside, right? So in every time you think about gateway, there's always two sides of some place, right? So
yeah. All right, let me switch to this view, I guess, and I'll let you start with it, take it off. Maybe if you can present the slides somehow, so it looks. This will. Oh, you have
looks
the.
all right.
I think it's very stretched. Let me see.
Yeah. Then I have a trick. So
if you have like a.
Yeah.
One of these days, there will be a software or a tool that will make all these things perfectly work on the first try.
It's my amazing widescreen monitor. But now, if I present this, should be.
Oh yeah, this is perfect. Yeah, perfect. All right, well, take it away.
Right.
The floor is yours.
So Ut number 60 from us, Peter and Alessandro, of course, from Solo. Let's get a deep dive, or let's talk about Gateway API, right? So it's a long time coming. We want to talk more about Gateway API. I think GA is on the horizon. As you know, next week we all gather in Chicago. So I think there's going to be a few announcements around Gateway API from us, from the community as well. So I don't know if you remember. I mean, I've been around for some time. I remember when there was no deployment object in Kubernetes. I mean, that time there was also no Ingress object in Kubernetes, right? There was a time when the only way to expose services was through a load balancer type of service, and that came with its own limitations, especially the proliferation of public IP addresses. So every service gets a public IP, every service gets every service of type load balancer should get a public IP, and it just doesn't work at scale, right? So it just doesn't work when you have to expose many services out of a single cluster. So this didn't last long. Around 2015, I found actually the blog post. We'll send the link. The very first incarnation of Ingress resources were born. So they were an extension to the networking group of the API of Kubernetes, and in fact they were part of extension. They were not part of the baseline of APIs for Kubernetes, and later on they became, of course, now they are fully integrated, fully GA since 1.19. So this introduced a mechanism to expose internal services to the outside through a single API, through a consistent and programmable interface called Ingress. So introduce two objects of very simple ones. The Ingress, one very simple, the Ingress class, which just describes the type of ingresses that you have available in your cluster. Ingress classes can be mapped to implementation of Ingress. Can be the same implementation with different parameters. I used to do a lot of AKS in Azure, and you sometimes want to have Ingress classes for exposing service internally through a internal IP, and another class that expose those services through a public IP. So you create two Ingress classes. So those describe the type of Ingress implementation that you have, and this big monolithic object called Ingress resource, right? So this was the way for Kubernetes to describe everything. So both the one side of the fence, like the public facing, the outside facing, the gateway side, we call it today, and in the same object you could define the backends, so all the routes, all the host name or path-based routes that traffic should take. So this works, and it works so far. I mean, and we today, as a matter of fact, that's what we all use, and it seems to be working all right. But there are limitations to this approach, right? So there are several and serious limitations to using the Ingress resource as it is today, and why instead we are moving towards a different implementation called Gateway API. So Gateway API is a project under the SIG network, the Special Interest Group network of Kubernetes. So it is an official project of the Kubernetes project, as implemented as a specification to define how traffic is routed into a cluster. So introduce new objects, more specifically the top part, the part that deals with the outside, with the let's say the client facing part of the Ingress, is expressed as a gateway resource, which is connected to a gateway class, which serves the same purpose as the Ingress class, as in defines the kind of gateways you have in your cluster. So every implementation of the Gateway API will bring its own gateway class to the table, and you can use it to attach those gateways to specific gateway classes, and then a bunch of user-facing objects like HTTP route, TCP route, and UDP route, and so on. So things stays the same. So in this case, like you still have a service attached to your gateway. If that service type load balancer, of course, you have a cloud load balancer, wherever you're running, Azure or GKE or AWS. you get a load balancer is provisioned, you get a public IP address attached to the service, of course, but then what happens inside the cluster really change. And it doesn't change, let's say, qualitatively, but changing the way we manage those objects. And it'll be clear in a second. So some differences between the Ingress API and the Gateway API. So this is a long time coming. It's been talked about and it's been refined for a few years already. Got into beta is 2022, and now the GA is near. Something that also I read today, and I was under the impression that, of course, Gateway API will replace Ingress. It actually is not. It's not gonna replace completely Ingress. So it is expected that implementers like the classic Ingress Ingress controllers like Nginx or the Ingress Nginx or Istio, they won't deprecate the Ingress API. So it's not a replacement per se, but it's more of an extension, something that you should use because it's a way better way to implement the same ideas of getting your traffic inside the cluster and then do something with it. So it's expressive, so you got more objects that can express better traffic routing within the cluster. It's extensible. That's the most important feature. So you can add your own filters. You can do some interesting. There's some extension points defined in the API, so you can bring your own CRDs and extend the behavior of the Gateway API. And it does everything that Ingress API does. So all the TLS and host-based and path-based routing, plus adds more meat to it, right? So makes things that are previously not impossible with Ingress API, but very dependent on the implementation and very dependent on tons of annotation. I don't know if you ever had to came up with some very complicated annotation of, for example, Ingress and Nginx to influence the behavior of the implementation of the Ingress API. The only way you could do it was through annotation in the Ingress objects, which is brittle. You have to go and think about and experiment with a lot of these annotations, and this gets completely, I mean, we get away with it through extension points, and the base object are really supporting in very interesting, very, very useful features like weight-based traffic splitting, and definitely supporting more protocols than just the HTTP focus of Ingress API.
So yeah. So if I try to recap, I looked into it as well, like this past week, right? But I'm learning about it as well. So thinking the first slide that you had, where we had, well, the way to get your traffic into the cluster from the public, right, from the outside, from the public internet, was to create the load balancer service, right? And the problem there was, well, you would, if you want to expose multiple services, you would have to create multiple load balancers with different IP addresses, and all that costs money, right? Like more load balancers means more money, right?
Yeah.
And then the Ingress API came in, and Ingress API said, well, what if you create a single load balancer, and that single load balance service of type load balancer that points to, I think they called it Ingress controllers, right?
Mm-hmm.
If I remember. So that Ingress controller pod was an instance of Nginx, for example, right? And then Ingress controller was then configured based off of this Ingress resource, right? And then the Ingress class itself here is just saying, is basically, if I go to like this is something that cloud providers would have, right, and implement, right? So if I would go to like AKS, AWS, any of the cloud providers, there might be already 2 or 3 Ingress classes on my cluster, right? That I could point to and say, hey, I want to create an Ingress resource using this Ingress class. Was it like that?
Yeah, in a way. But I I remember very distinctly, like deploying the same Helm chart of Ingress controller, the Ingress Nginx controller, with slightly different parameters, specifically the Ingress class name. And one Helm chart would deploy the Ingress controller with public IPs, I mean, of type service. In Azure, you have an annotation to the service. You can define if that service gets a public IP or a private IP in the VNet. So I would deploy, and I did this quite a lot. So two Ingress controllers with slightly different names of Ingress class, and different annotations on the service, right? So on this service, those were two Ingress classes that developers, I mean, the users of the cluster could use to either choose to deploy a public-facing, like a internet public IP, or a private-facing Ingress. So this Ingress class actually is not in there until you deploy an Ingress controller. So there's
okay. So so you have to do so you have to do the Ingress controller first. Then you would create the Ingress resource that points to that Ingress controller, right? And then with the Gateway API now, what you're doing is you don't have to deploy the controller per se, right? You basically, with the creation of the Gateway resource, right? Once you deploy that resource, you're going to get an instance of the, I don't know if they're still calling it the controllers, right? But you'll get an instance of that something that knows how to understand the, well, not understand, that implements the Gateway API pretty much, right?
Yeah,
and knows about those resources, right?
That's pretty much it. So the Ingress controller in the old days, I mean the current days, there's no representation in Kubernetes. There's no object defining an Ingress controller. It's something that you deploy with Helm or whatever.
Okay.
But in the Gateway API introduce an object, and Kubernetes native object called the Gateway, which represent an implementation, like an instance of this Gateway class. And indeed, when you create the object Gateway, it does create a pod that is your implementation. Depends on implementation, of course. Like in Istio would be an Istio Ingress Gateway based on Envoy. If you have Ingress Nginx, would be an Nginx pod, of course. But they're very, very tied to the kind of gateway API implementation you have. So it's still very dependent. These are APIs defined for the whole ecosystem, right? So it's just implementers like Ingress Nginx, Istio, Linkerd, they adapt to the API, right? So they comply to the API. Yes.
Yeah. So that's the difference that I was trying to notice as well. Is previously, right, you would deploy the controller and then you would deploy the resource, right? But right now, you have to have some sort of a control plane or something that implements the actual Gateway API, like in Istio, right? Istio-D implements that API. So whenever you create a Gateway API gateway resource with a gateway class called Istio Ingress or whatever it's called, right? The Istio-D will go and create a deployment, right? With the instance, with whatever, however they want to do it, right? However Istio wants to do it, however they implement that for their ecosystem for in their world, right? If it's Nginx, if it's any other implementers of the Gateway API, they'll have their own. It's not going to be Envoy proxy. It might be Nginx. It might be something else, right?
Yeah. Again, the logic stays in the implementation, right? So Istio-D now watches for this object of type gateway. Once they are created, it knows what to do, which is to create a pod with Ingress, with Envoy, of course, with all the specification, of course, that you set in your Gateway API object. So, the implementation can change, but from the point of view of the user, that there's one single API to deal with, not many. So yeah, that's one thing that really stands out about Gateway API. Like it's a way better Ingress API, but also
Mm.
extending. And I'll show you a few things you can do with the
Mm.
filters and
Yeah.
extension file.
Well,
That's very cool.
yeah. One question that popped up,
Oh.
and I think we answered it already, but just so we're on the record, right? So the question is: so Gateway API ships with a default implementation. I thought our cluster should still have something that implements the Gateway CRDs. It
No.
doesn't, right?
No,
That's the
no, that's by
yeah.
design. By design, it's
Yeah.
stated on the Gateway API docs. There's not going to be a reference implementation of Gateway API. Like there is no, of course, like everybody for Ingress API, of course, most people I know, Ingress and Nginx is under the Kubernetes organization, of course, but it's just an implementation. And so for Gateway API, there won't be a single golden standard, so everybody is going to be free to implement it as best as
The
they
best
can.
it's for them, right? For
them,
their
yeah,
whatever. Yeah.
of course. That's but this is so cool because it gives you already a bunch of very it's a very feature full, right? So there's a lot of stuff in there you can I have a slide about like if I still need a service mesh, but so the real advantage here is that by splitting the objects, you can, of course, like objects in Kubernetes, they obey role-based access control rules, right? So you can literally restrict application developers, people that just have to, create their services and expose them. You can restrict them to create gateway type of object, right? So because they are now separate objects, they can obey different roles and they can be assigned to different roles. So really the Gateway API introduced these personas, right? So the infrastructure provider, which is the person or the people, the team that deploy the clusters, and they can define what kind of gateway classes to are available by installing literally on chars, operator, whatever, the implementation of choice. Istio, of course, we love it, but there are many others, many other available. Then there's a cluster operator, which is somebody like cluster admin, somebody that can have control over multiple namespaces, can define the client-facing side of things, like the gateway, which defines the host names, defines the TLS property, and so on. So those are the gatekeeper, so the persona that defines this high-level object, the gateways. But then the application developers are free, or like they are empowered to be able to expose their services as they see fit by creating these HTTP routes. And of course, they're also in charge of creating the services, right? Because they are in charge of deploying their application from end to end. So deployments, services, and now HTTP route, because that defines how the service is accessed from outside. Path-based routing, or waiting, or header manipulation, so on. So it's really a division of roles that really makes sense.
Yeah.
And I hope people agree to that.
Yeah, and it's also, if I remember correctly, with the Ingress resource, you had single Ingress resource, right? Where it was pretty hard to share it, or like let's say two of us are developers and we're responsible for our own services. With Ingress, we would define it in a single, right, Ingress resource with a single host name, and then the paths. So I could theoretically mess up your stuff if I wanted to, and vice versa. But with this, with the Gateway API, I have access. I don't have access to the gateway as a developer necessarily, as to the gateway resource. I mean, right? That's
Indeed.
something that the operator creates. However, I am free to create my own HTTP routes, decide which gateway I want to attach it to, and what are the rules for accessing my service behind it. Right?
Yes. So that's exactly it. So the thing about the Ingress, which of course, like we're gonna keep using for a while. I mean, let's be honest, we're not gonna migrate to Gateway API all of a sudden. it is a monolithic object that defines everything from Ingress to the backend. And so, but developers don't really want to should not deal with all the TLS route, TLS configuration, and what host name to choose. They should not be in charge of that, and so their role should be just to define the route, either HTTP, TLS, or gRPC or something, and the rest should be a responsibility of the cluster operator, right? So that's it's one big advantage of using Gateway API is that the separation of concerns, which is the guiding principle of what we do, right?
Yeah, and then you can basically do, if you, depending on how you share your cluster with the developers, you can apply like RBAC rules, right? On like you can say, oh, this namespace is my namespace, and I can do whatever I want in that namespace, but I can't touch Alessandro's namespace or someone else's namespace where they have their own stuff, right? So we can apply the rules in a more, I guess, not dynamic necessarily. It's more fine-grained in a way, right?
Indeed. Maybe I'll fire up the Gateway API documentation because there's a nice diagram there. So you can also share gateways between namespaces, right? So that's another thing you can do. I'll find the link and I'll find the right image and I'll get it there. So, and of course, it's not only HTTP, right? So the world is not made of only HTTP requests. There's much more out there. There's TCP, of course, and gRPC and UDP. And so far, Ingress failed to provide mechanisms to route this kind of traffic. And so Gateway API fixes that because it introduces routes as a generic object route, but then it's divided in multiple objects, about 5. Keep in mind that some of these are part of the experimental channel. I didn't know that. So they actually, when you install the Gateway API, you can choose the standard channel and the experimental channel. And so if you look at some of those objects, then you do see that some of them are part of this experimental channel, right? So see this node under TLS route. So just so you know, you have to actually install the experimental
CRDs
API
and everything.
Yeah, the CRDs, yes. So
but then it's also it's experimental from the API side, but then it also depends whether your control plane implements that, right?
Exactly.
As well. So
I mean, the whole API is beta, right? So it's beta according to the Kubernetes definition of beta, right? So this is a beta level API. So it's expected not to change that much, but within that there are some experimental feature, of course. So the big question is: do I still need a service mesh, right? Or do I still need an Ingress implementation? Yes, you do. Yes, it's this is more of a backend change. So to unify and to extend the API, so they are more useful for a lot more people. So yes, don't throw your Istio or Ingress and Nginx away, because you're still gonna need it. You still need something that implements the Gateway API to use it. So that's,
I mean, even though people might say like, oh, there's a Gateway API does weight-based traffic routing now, or it can do mirroring now. It's like, yeah, but you still need something, you know. Something has to know, like, yeah, you can configure it, but someone has to enforce that and like create the lower level configuration and actually do that for you, right? Which
it just defines defines a way to express weighted routing in a new API. But yes, it is Istio that actually does the job of really moving
like splitting
traffic.
splitting the
Course,
traffic correctly and everything. Yeah.
It's a purely an API implementation. Then, of course, there's also the Gateway API for mesh management and administration. Great name, of course. It's called Gamma, like the gamma rays that made Ulk. It's a initiative within the Gateway API that helps defining how to use Gateway API in a service mesh, which has its own culprits and quirks, of course. So, because service mesh, of course, there is a lot of overlap. For example, this weighted or how do you attach routes to a service mesh. So there's a whole initiative that specifically aims at simplifying the implementation of Gateway API for different service meshes. And of course, there's people from the community working on this initiative, of course, and we are monitoring very closely and contributing as well to make sure that people using service mesh will adopt Gateway API easily and in the most natural way.
Yeah. So this is the idea here with the Gamma initiative is like typically the Gateway API was for like north-south traffic, right? Like traffic coming into your cluster.
Mhm.
But this is also focusing on what happens with the east-west traffic, right? Traffic within your cluster. And is there, I guess, a way to express those things with a Gateway API resources as well, right?
Yeah, of course. So yeah, it's something that you, again, like a very early stage, or like still figuring it out a few things, how to really implement this at the with Gateway, how to implement the service mesh, for example, east-west traffic, very big use case for service mesh through Gateway API. So that's something to look at.
Yeah, so you could do things like timeouts and whatnot and all those.
Yeah.
Yeah.
So the API can grow, of course, but so just want to go through some very cool stuff that I find out while I was looking into Gateway API. One thing is that you cannot do with Ingress today is having a HTTP or an ingress in one namespace referencing a service in another namespace. That doesn't work with Ingress API. It just fails. But Gateway API introduce a new object called reference grant, where you can say a specific object. So in this case, HTTP route can reference services in another namespace. Actually, at the bottom of the documentation about reference grant, the Gateway API maintainers wrote that this could be a quite generic object, right? So it could work outside Gateway API as well, like making sure an object can reference another object from another namespace. So actually, maybe so that they warned that maybe one day this kind of object will be outside, will be moved away from the Gateway API.
Like a generic thing, right?
Think about it. It makes sense, right? So we don't have a way to export an object to another namespace and make sure that you can reference that object. We in Kubernetes there's no such a thing yet, but this is a first attempt within the Gateway API to allow object from namespace X to reference a service, for example, in namespace Y. And that could be very useful. You can have like a shared services that need to be referenced by multiple routes in multiple namespaces, and this works in Gateway API right now by using this reference grant object. So
this is basically, if we mentioned it earlier, right? The whole Alessandro takes care of his services, Peter takes care of his services. With reference grants, if I read this correctly, I could basically, the admin, right, can create a reference grant or someone and say, hey, you can reference the services in this namespace, in Peter's namespace, right?
Yeah.
From an HTTP route that's in this other namespace, maybe, right? Or me giving you access, right, to my services if you want to use them in the HTTP route, right? But if I haven't tried, but if I would try, let's say this is deployed, and then what would happen if I didn't have the reference grant? It would just fail. It would just say
it will be
oh,
invisible, right? So, but that's exactly the use case. So me as a owner of this service in the backend namespace, I can decide who can reference me, right? So who can reference this service, and I can block it. Of course, this goes on top of the usual network policy. It's not about traffic here. It's about Kubernetes object referencing other objects in different namespaces. So it's a you can do the same,
So this is basically having like namespace scoped references, but then with the reference grant, you're basically making them cross namespace. I don't want to say cluster wide, but cross namespace, right?
But
or cluster wide if you want to in the end, right?
Yeah, in this case, I think if you remove the namespace in the from, maybe you are giving the ability to every object of type HTTP route
and all that,
to reference your service. Yes. So I have to look into it, but it's an interesting one and something really. I mean, it's a very smart implementation of cross namespace referencing. With the routing, again, something you could do with service mesh today, right? But why, we've been doing this in, of course, most service mesh implements with the routing. I've been doing this with Ingress as well, but it involved a lot of annotation for Nginx, trying to influence like the behavior of Nginx. It was pretty messy, and this is so easy, right? So it just adds one field called wait, and the gateway will send. I think I think there's also an implementation for different load balancing. How you call it? Protocols? No, load balancing
algorithms. Right?
Algorithm. Thank you. For this, right? So you can be very smart about what to do with your traffic, like send a bit here, and make some decision based on the weight. So it's and by the way, also Gateway API is supported by Argo rollouts right now, right today. So there's a Argo rollout plugin for Gateway API. So you can, if you don't know, Argo rollouts is an extension to Argo, the Argo project, Argo CD project, that can help you perform progressive delivery of your services. Right? So as you deploy a new version, the Argo routes, by manipulating HTTP routes, and there's a plugin for Istio, of course, manipulating virtual destination virtual services, of course. So there's the plugin for Gateway API will just manipulate the HTTP route object in a way that your service is being progressively served by the new version coming up. So that's pretty awesome, and maybe we should have a demo about this soon enough. But that's it's very exciting that you can integrate Gateway API with third-party tools like Argo CD, right? So and I guess Flagger as well is something for Gateway API.
So there's a question. So a controller like Istio would anyway need cluster-wide access. What are we gaining from reference grant? Maybe I'm missing something.
So, well, the reference grant is an object that allows you to very specifically export a service to other namespaces, while today you can't, right? So you can't reference a service in one namespace from an Ingress resource in another namespace. So you have to create a resource in there. So it's it allows you for the service owner to export them to the right namespaces to have more control over who access what.
Yeah, so it's I'm trying to think an equivalent of so I have a gateway running somewhere, right? And then I have multiple services. I'm gonna have routes in different namespaces as well, right? Theoretically, right? And then with this grant, we're basically saying because the HTTP route can only see the services in the namespace that it's deployed to, right? Is that the case? Right? I think that might be the case, right? So HTTP route can only uh, talk to services, I guess, or route to services that are in the same namespace. But if you want to do it cross namespace, you explicitly have to go and say, hey, I'm allowing this specific HTTP route I'm allowing HTTP route from this namespace to point to services in that namespace.
Yes, because the HTTP route in the full namespace here is a backend refs to another namespace, so that is not going to be allowed unless you have a reference grant. So,
and that's because HTTP route is then namespace scoped, right?
Yes,
it's
of
not
course,
cluster wide. Versus an Istio, right? The difference there is that in Istio, by default, right, virtual services and everything else is mesh wide, right, cluster wide.
Yeah.
And then you can use the export to field to say, no, I only want this service to be like visible in this specific. So it's like it's put on its head, right? It's the other way around.
The other way around. So you explicitly have to allow, while Istio it's
but
allowed.
You have to lock it down in air quotes, right? Or scope it down, I guess, not lock it down.
Yeah. I'll just go quickly because I guess do you have a demo? Do you want to show something?
I can do a quick demo if you want to.
Okay, just something very cool that, of course, again, this was the prime use case for service mesh, right? So manipulation of or matching headers of requests. So HTTP route is a pretty complicated, or like a very extensive object. You can do a bunch of things. One is the header matching, so you can send specific, because matches is an array, right? So you can say this, when you match this condition, like a regular expression in the user agent in the header, do this. In this case, send it to this backend. Otherwise, send it somewhere else, right? So you can send mobile traffic to the mobile backend. In this case, we've been doing this with Service Mesh for a long time. The good news is, I mean, now you have more of a standard way to express this kind of routing through the HTTP route. So I'm not sure about if Istio implements this already, but definitely is part of the HTTP route API.
Yeah, because Istio basically, when they say we implement Gateway API, or when will they say we implement it completely, right? They'll be basically, instead of listening, in addition to listening to virtual service resources, right? Istio's virtual service, translating them to Envoy, they'll be listening to HTTP route resources and then translating that to Envoy, right? So
I'm not sure if maybe Istio choose to translate the HTTP route in a virtual service or directly into Envoy configuration.
That's true. I don't know either. I don't know.
You could. I mean,
theoretically, they might say, "Oh, it's easier just to do virtual service and then use the same existing path already." But I really don't know.
We could, this can be done in a virtual service. I mean, we pretty much, if you give me 5 minutes, I'll probably come up with a virtual service that does the same thing, right? So, it's not completely unreasonable to have a translation layer from HTTP route to virtual service, and then because then you can also still use the virtual service object natively, or make them through the HTTP route. So that's it's something interesting to look forward to, how this will be implemented. More things. So, and this is great because this implements filters, as in filter can modify. So there are different type of filters that can modify an header, add or remove or mutate headers in HTTP request. And this, of course, this HTTP route. So we're all dealing with HTTP, with headers and bodies and everything. But of course, like you can also deal with TCP route, UDP route, and gRPC route, which implements part of these features. gRPC route is very similar to HTTP route, as in implements a bunch of things like headers, matching, and so. But this what we show here is pretty much what is part of the HTTP route object API. So yeah, you can modify headers in HTTP request. Again, something you can do in Istio right now, in many other service meshes as well, but definitely is the strong suit for us for a service mesh. So this means that if you probably the implementation will maybe different implementation will not implement every feature, right? But I hope and I suppose that Istio will implement most of these features because they are really part of the core of Istio.
Yeah. HTTPS redirect.
Yeah,
So
also
yeah.
Something I always wanted to look into because, of course, it's in Ingress. It's quite trivial, but again, it's also pretty easy to do in with Gateway API. You implement a filter that redirect every request to the same, but with HTTPS. So it changes the scheme of the request to redirect.example to it sends the 301 code, which is a redirect, and so the client will just redirect itself to the HTTPS endpoint. So this is a pretty neat way to express what we had to do, of course, in Ingress resources in different ways, but this is very simple way to do this HTTPS redirection. Finally, this was very recent, few days ago, really. There was this blog post about Ingress to Gateway. Again, I'm so sorry that Gateway API doesn't have a logo yet. Maybe
I think it does. I think it does. Yeah, okay. I just saw like earlier Ian said that Gateway API has adopted a logo.
Oh, so, okay.
I don't know what it is, but I guess we'll find out soon.
Every project needs an awesome logo to be successful. I mean, come on, it's part of the deal. So it's a very simple tool that will take your Ingress resources and just spit out the equivalent gateway resources. How cool is that? I mean, so you really have to, no excuses now. You can feed the Ingress resources to the tool and just get the ready to implement Gateway API resources. I mean, it's part of the. I think it's actually under the Kubernetes SIG. So I think it's gonna be. I'm gonna use it a lot. Yeah, that's all I have. But of course, like we'll feel free to. Is there any more questions on YouTube that you know?
Yeah, so there was GK was saying like about reference grants specifically, right? Shouldn't we define another HTTP route in a bar namespace, and then just trying to understand what practical situations would prompt us to delegate with reference grants? So one practical one is you. It's not only for HTTP routes; it's also for secrets, right? So if you're doing like terminating TLS, right, you could reference a secret from a different namespace. That's another thing that it allows you to do. But I think it's from what I've read, it's just a way that it's. I hate to say it, but it's by design, right?
Yeah.
By design, you can only reference services that are in the same namespace. If you want to do it cross namespaces, you'll have to do this reference grant. And I think the idea here is because that way you can enforce, like if it's namespace scope, you can enforce like RBAC rules and actually have, instead of one giant HTTP route resource, right? You can have multiple smaller ones, and you can delegate them to different people, right? So I think it makes it easier to do RBAC in a way as well, right? Not
Yeah,
just
maybe, or maybe, because in this picture there is no gateway, but HTTP route reference a gateway. So maybe I'm allowed to reference a gateway from the store namespace, but I'm not allowed to reference a gateway from backend because I don't want to expose my backend, right? I want to only expose it to internal services. So
yeah.
maybe that could be something that the people behind the reference grant, I think I hope I'm gonna meet them at KubeCon and ask them the question. But yeah, it's if you notice at the end there is a notice that it's a very powerful object that can be.
Yeah, they're
used
thinking
for
of like
this.
adopting it outside of
Yeah.
outside of it. All right, let me do. Thanks for the slides and the presentation. I can do like a very quick demo. So I have a clean cluster running, and the first thing that I'll do is I'll apply the Gateway API. I'll do the standard installation. This will apply all the CRDs, create the
It,
namespace, the
just,
addition.
just so you
Yeah,
see that there are a few missing, like TLS and GRP, because you do the standard.
because I went with the
Changes
standard one. Yeah, yeah,
changes to
yeah.
experimental, and you get all the
The
shebang.
experimental ones, right? So the other thing that I'll do, I'll install Istio, but I'll use the minimal profile, right? Because remember, you don't have to use the demo anymore or default, since we don't necessarily need the Ingress gateway that's deployed with Istio, right? Because we're going to deploy it when we create the gateway resource from the Gateway API. So let's do that. And all this should be fast enough. There you go. So let me just double check. And while I'm doing this, if anyone has any more questions, feel free to ask. So I have Istio installed. I just have STOD running. And then what I'll do next is I'll label the default namespace for injection, and then I'll deploy HTTP bin. Nothing too crazy. Let's do that. And we can wait for this one. So I have Kubernetes cluster with the Gateway API CRDs, with Istio, and this HTTP bin as well. Next time I should preload the images, but all right, there it is. So I have the HTTP bin running. It's there. And then also let's list the gateway class resources, right? So you'll notice that there's the gateway controller named Istio, right? So if we do Istio YAML, this is how it looks like. There's nothing too crazy there, right? It's just this is the default Istio gateway class, and there's a controller name, Istio.io gateway controller. So let's see if we wanted to expose that HTTP bin. I also have a service, by the way. Didn't show that HTTP bin service. So if I wanted to create a gateway, I'm going to use the gateway class name Istio, right? That's the one that we showed. And I'm going to create a listener. So this is the gateway resource here is very similar to the gateway resource in the gateway resource from Gateway API is very similar to the gateway resource in Istio. That's what I wanted to say. Whereas you're basically saying, "Hey, I want you to listen on this port. This is the protocol, and this is the host name." Right, and then you can additionally say, I'm allowing the routes from the same namespace, right? So you can like lock it down that way if you want to. So let's deploy this one. So I have the gateway. It's not programmed, right? And then let's do, whoops. So what happens if I list, notice that there's a new pod that was created called HTTP bin, which was the name that I choose. This is the name that I choose. and then HTTP bin gateway Istio. So this is an instance. This is an instance of Envoy, right? So this is the same Ingress gateway that you would create when you create. If we would deploy Istio with default profile, right, and create and deploy it with the Ingress gateway there. Then, if you wanted to, well, let's see. Well, let's just do. Let me just show this how to expose, right? We would create a route, and we'll say the parent for this route, the actual gateway, is this gateway that we created. This is the host name that we're listening to, and these are the rules, right? These are the rules that are saying how to match the traffic, and then where to route the traffic. So for the match, we're just doing path prefix. So we're saying httpbin.example.com/get. If that matches the request, go to the HTTP bin service on port 8000. Right. So if we deploy this one. I didn't do metal LB. I know I forgot something. Anyway, that's gonna be fast. That's why I don't have the IP address here. But
I give a shortcut to install MetalLB.
yeah.
just a note. So in this case, of course, like this gateway is in the HTTP namespace, so it's really specific to that application, which I don't think is going to be the usual way to deploy this. I mean, if we want to stick to the old way, which is one ingress per cluster, we gotta do different things, right? So because in this case, like this code, it's in that service and that pod, they exist in the HTTP. So we go back to the proliferation of public IPs and services. So
true. I mean, you would theoretically, right? Not theoretically, also practically, you would create an namespace called Ingress or whatever.
Istio Ingress, yeah.
Right. That's where you would deploy your Ingress gateway. That's where you would create. That's where you would create that gateway resource, right? And then
the routes will attach to that gateway.
Yes, and those routes, then you would be creating in a different namespace.
Yes, of course.
Right, and that's where you would do the you would do that reference grants, right? Question: I always feel that there will be a learning curve and adoption curve with the gate, of course. Yeah, unfortunately there's not. With all the new stuff that comes out, there's always a learning curve. But I mean, if you've done Ingress resource, if you're familiar with the Ingress resource, I don't think there's a lot of necessarily. It's not that different. Right, it's a different paradigm, maybe a little bit, but you're still trying to do the same thing. And then another one: is there any practical benefit of migrating to Kubernetes Gateway API from, let's say, Glue Gateway or Istio Gateway? I mean, how often do we change our API gateway solutions? I mean, it depends what you're using today. I know Glue Gateway does support, right, Gateway API, right? So if you're using Glue Gateway, you can start using the Gateway API resources. Migrating.
I think maybe the question is.
It's more. I mean, you're still gonna be. It's not necessarily migrating from like a API gateway per se. You're almost like you're migrating the resources, right? Your gateway is going to stay the same. You're still going to have an Envoy proxy, for example, as your gateway. It's just how are you going to configure it, right? Are you going to configure it using Istio gateway resource, or are you going to configure in virtual services and destination rules, right? Or once everything is implemented, are you going to use HTTP routes, TLS routes, and other resources from the Gateway API to configure the same thing? It's going to be the same thing, right?
And as I find out today, I mean, you will still be able to use all the native Istio, Ingress, or Nginx or whatever features, because they're not gonna go away. I mean, also the Ingress API, apparently they are not gonna go away. So you still be able to create an Ingress resource and do everything you need to do. The Gateway API is a new way to express the same thing.
Mm-hmm.
And the power resides in the separation of concerns and special duties, and that you can do much more things with Gateway API than just simple Ingress. Unless you use, of course,
it's more flexible, right? I
Yeah.
would say it's more flexible, flexible way of configuring these things. So while Alessandro was talking, I did I did went through the demo basically, but this was just let me show you. When I deployed the gateway resource, I got the load balancer. Now I have the external IP as well because I deployed the Metal LB. And then if I make a request to that external IP on a /get path using this host, I'm going to get back the response, right? So this is still Istio Envoy, right? Because it's Istio, it's Envoy instance, right? So it's fairly straightforward.
And there is no virtual service object of any kind, right? So
no, I haven't deployed any, like there's no virtual services, right? I don't have any virtual services or nothing deployed.
No, just the HTTP route, like
yes,
purely.
Yeah. So if I wanted to do this with virtual service, I would have to create a virtual service. I would basically just similar. Let me see, similar logic that's here. I would have to express it into virtual service, right? If you remember virtual service, you have host names, right? You can attach a gateway as well. And then you also can come up with the matches and the rules on how to route the traffic.
Again, one object to define both the host names to respond to and the routes of the service side. While the HTTP route attached to a gateway that already exists and defines the host names and just limits to limited only to define the routes where to send the send the traffic.
I mean, it's in a way like Istio has that separation as well, right? Like in the gateway resource, these are the ports and hosts I'm listening for, and then you're attaching the virtual services to the gateway, or attaching gateways to the virtual services, right? But in this case, you have the HTTP route, right? And then specifying. The nice thing is I think it's more expressive, I would say. Wish they coined different terms instead of overloading the term gateway. It's confusing. Yes. That's the my thing is the service, right? The word service and also the word cluster. Like it means so many different things and different in different contexts, I guess. Could you please go over again the differences between the Istio Solo Gateway and the Gateway API Kubernetes provides? So Gateway API is just an API to configure an Ingress, a proxy, right? So it's just an API. There's no implementation, right? When we're talking about Gateway API, there's no implementation behind it, right? You still need a glue gateway, or you still need Istio's Envoy, right? The Ingress gateway to actually do the routing for you and do those rules, right? Does that make sense?
Maybe conceptually similar to the container storage interface, container networking interface. It's an API defined at the high level by the Kubernetes community, and then you can implement it in any number of ways. Container storage interface can be implemented by NetApp, can be implemented by whatever. As a container runtime interface can be implemented by Docker, Containerd, and so on. You are free, so it's like not even batteries included because there are no batteries. You have to bring
Yeah.
your own batteries,
You
right?
have to bring the batteries. You get the cables and you get the screen and you
Exactly.
get the buttons and you get everything. You just need to like bring your batteries, I guess, or your. It's. I mean, maybe I'm pushing uh, uh, the the idea, but it's almost like electricity in a way, right? Where like if you have a device, there's a standard, at least in the US, there's a standard in the like UK, there's a standard in Europe for the plugs, right? So it's the yeah. So there's a question from Mark. I guess we're in a question portion now. I'm done with the demo as well. Could we use WASM code as custom HTTP filter in Gateway API, such as Istio could use WASM? Alessandro, you might.
I think not. I mean,
No.
as far as I understand, not yet. No. Don't see anything in the documentation that points to WebAssembly filter in any way. So, because this is not a very generic thing to do, right? So this is very dependent on Istio and Envoy, really Envoy implementing WebAssembly filters. But you can pretend that every implementation out there would be based on Envoy, right? So you like Ingress API, Gateway is also like the minimum common denominator, right? So they have to agree on some sort of minimum set of features that everybody can implement. But if they start implementing like WebAssembly, they probably like making too easy for the Envoy-based implementation and more difficult for other. Because, for example, Nginx would maybe like to use Lua, right? So it's a bit different mechanism.
But theoretically, I'm not saying that's a good idea, right? But theoretically, there could be a way to come up with extensions or something that are native to the HTTP route, for example, right? Or can be included in the HTTP route, and then each control plane could decide which one it implements, right? Like, and if you're using Istio, yeah, you could use the WASM theoretically, right? Because Istio knows how to do that. And then you could use Lua script maybe if you're using Nginx or Istio as well, right? But
I think I will look into it, but there are extension points, right? Where you can actually bring your own CRDs, extra CRDs, and do things that are not part of the base API. I gotta look into this, of course, but there is a part of the documentation. It's not very fleshed out yet, at least from my point of view. But there are extension points where you can actually bring your own. But I haven't seen any real use cases out there or implementation.
yeah, and Marino is saying that it does not offer the WASM functionality directly, right? Which, yeah, I mean, you could still, if you're using Istio in a way, it's you still have an Envoy ingress, right? So it's still Istio. Still, you can still use the WASM. What is the WASM plugin resource, right? If you want to run specific WASM, like specific filter and target that on the gateway, right? It's gonna know how to do that, right?
Yeah, I mean, because you are running Istio, there's Istio-D. So, okay, if you cannot do it through HTTP route and objects, then you gotta resort to use a virtual service, right? So where you're
Yeah,
free to use
yeah.
the Istio specific and voice
Yeah,
specific.
yeah, but even like in this specific case with WASM plugins, there is a dedicated WASM plugin resource in Istio, so it's not even virtual service, right?
Yeah,
So
I mean, the Envoy filter.
yeah,
Object,
yeah,
of course.
yes, yeah. It's a WASM plugin, and then you say here's where my here's where you can download it from this repo, and here are all the proxies that you can apply it to, right? And I think I'm not sure. Maybe I'm like speaking too much here, but I think it does support gateways as well, right? So yeah, it does, of course. Yeah, WASM plugin does support gateways as well. All right. Thanks everyone for showing up. If you still have questions, feel free to either you can reach out to either one of us on Twitter or email. We're also on Solo Slack. So if you go to slack.solo.io, you can join us
And
there.
we are in Chicago, of course. Do you remember the boot number? Ah, damn. I think okay. You can find us, of course, at in Chicago at KubeCon, of course.
Yeah.
Boot D11. Boot
D11.
D11.
Okay. All right.
D11. So you
One
find
more.
me and Peter.
Yeah, and Marino and everyone else. One more question popped up. I know we're over time, but are there any suggestions, best practices, or benefits to using Gateway API instead of Istio Ingress Gateway if we're also using Istio as a service mesh inside our cluster? I mean, I would say don't move just for the sake of moving, I guess. Right? If you're already using the Istio's gateway resource, I wouldn't necessarily tell people to move, right? Unless there is a scenario or a use case where the gateway API features would, you would get benefits out of those features, right?
I would say portability, right? So there is a distinct advantage of using objects and APIs that are adopted by a large community, right? So you can rely on the power of community to make sure that those APIs are solid and taken care of. That's my 2 cents. And you can always move implementation by keeping the same object, right? So by keeping the same same base.
Yeah, but it's also, I mean, think to mention it is still experimental, right?
Yeah,
so it's you wouldn't want to move necessarily right now, but so it's I'm not gonna say experimental. It's a beta, right? So Istio has the beta support for the Kubernetes Gateway API, but Istio does intend to make it the default API for traffic management in the future.
Yeah, definitely.
So,
Istio still watches for those objects, so it does something with those objects. So you just have to install the CRDs, right? So that's the only thing. And I wish eventually they would become part of the base CRDs of base objects. There won't be a CRD anymore because it's not custom. Who knows? Eventually, we will get there.
Yeah, but it's not like this is going to change tomorrow, right? It's going to change in the future. It's going to be the default one in the future, but the existing API will still be supported, right? The Istio APIs will be supported as well. It's just looking into the future. That's where it's gonna go.
Yeah. Well, I gotta go trick or treating with the kids. So
yeah. All right, everyone. Thank you, Alessandro, for preparing this. Thanks everyone for the questions. And if you're in Chicago next week, look us up, say hi, stop by our booth, D11. And if you have any questions, Slack solo.io or find us on Twitter or somewhere else online, I guess. And we'll see everyone in a couple of weeks for Hoot number 61. Thanks, everyone.
Thank you, Peter. Thank you,
Bye.
everybody. Bye.